Almost not good. All right. So we discussed yesterday that we could not leave square roots or cube roots, any kind of radicals in the denominators of our fractions. And we talked about a couple of examples yesterday to simplify those. We're going to get a little bit further into it today and also look at what happens when we have the entire fraction under a radical, because that's not allowed either. And then we're just going to learn how to simplify a lot of stuff with fractions and radicals. So number one, I am asked to simplify 6 over the square root of 5. And just like we discussed yesterday, we cannot leave a radical in the denominator of a fraction. And we did a couple of examples like this. If I wanted to get rid of the square root of 5 in the bottom of that fraction, what is it that I'm going to multiply the top and the bottom by? The square root of 5, right? We multiply it by itself. Be careful with the values or the numbers that you're actually multiplying at the top. That 6 is not under the square root. The 5 is. Can I actually multiply those to get 30? No. When I multiply a number that's not under a radical by a number that is, it just stays on the outside. Okay, so that's just going to be 6 times the square root of 5. And then at the bottom, the square root of 5 times the square root of 5, they are both under the radical, so I can multiply, and that's going to give me the square root of 25. And then I need to go through and simplify everything that simplifies. At the top, does 5 have a perfect square in it? No, right? So that 5 is going to stay under the square root. And then what about the bottom? Is 25 a perfect square? What is the square root of it? Then what we try to do is simplify if we can. We can only simplify numbers that are both not under the square root sign or numbers that are both under the square root sign. What are the only two numbers that are not under the square root sign? 6 and 5. Do those have anything in common? No. So I'm going to leave my answer just like that. Go ahead and try the next one. I've got 10 over the square root of 10. I am not allowed to have a square root of 10 in the denominator, so how am I going to get rid of it? Multiply the top and the bottom by the square root of 10, right? At the top, do those 10s actually multiply together to give me 100? No, one is not under the radical, one is, so we're going to have to leave them just like that. But at the bottom, the square root of 10 times the square root of 10, I can actually multiply those and get the square root of 100. 10 is not a perfect square. It does not have a perfect square in it, so I cannot simplify that. But what is the square root of 100? 10. Do you see anything here that can simplify? Yes, what? The 10s that are not under the radical? And they basically cancel each other out to leave me with just the square root of 10? Let's take a look at 3. This time I have an entire fraction under a square root sign, which is also not allowed, that it's not completely simplified. So when that happens, the very first thing we want to do is we want to split it apart. And what I mean by that is we want to take the square root of the numerator and we want to take the square root of the denominator. From here, we can do this a couple of different ways depending on what you realize. Does anybody see anything that's going to keep me from having to do too much work? 16 is a perfect square already, isn't it? So my denominator is a perfect square. So what I can do is I can go ahead and take the square root of 16 and change that to 4. What about the numerator? Does that have a perfect square in it? So that's going to stay. Is that allowed as an answer? Yeah. Okay, so sometimes we get lucky and our denominator is already a perfect square. Now, could I have multiplied the top and the bottom by the square root of 16 and gone from there? Yes, it just would require me to do quite a bit of work and a little bit more simplifying. So just keep an eye on that. Look at your denominators. Check to see if they're perfect squares before you start multiplying. Sometimes they will throw one of those at you. Anybody have any questions? Do you want me to do it the other way? Okay. So if I had this, let's see, the square root of 3 over the square root of 16, the first thing I would do is I would multiply the top and the bottom by the square root of 16. So at the top, that's going to give me the square root of 48, 256, I think. Somebody with a calculator check me 16 times 16. Is it 256? Okay. And then what I can do from here, square root of 256 is going to be what I just multiplied by itself. But I have to look at this top part. Okay, so I have to see if there is a perfect square in it. 48 is not on my list, so I would start at 36. That does not divide into 48. 25 does not divide into 48, but what does? 16. So I can split that up into the square root of 16 times the square root of 3. That square root of 16 turns to 4. And then I would be able to reduce the two numbers that are not in the radical by dividing each one of them by 4. So that would turn to a 1. And I would end up with the same answer. It's a little bit more work because you're going to simplify more. Is everybody okay with that? Kind of, maybe. All right, I want you to try number 4 then. Okay, with number 4, the first thing I want to do is I want to split it apart. Anytime you have an entire fraction under a radical, you're going to take the root of both the top and the bottom. Does 5 happen to be a perfect square in this one? No. So I am going to have to do some work. What do I multiply the top and the bottom by? So we're going to multiply by the square root of 5. At the top, can I actually multiply the 2 times the 5 and get 10? Yes, because they're both under the square root sign. At the bottom, I get the square root of 25, and we're going to simplify. We know the denominator is going to turn to just 5, right? Does 10 have a perfect square in it? No. So it's just going to stay. And so my answer would be the square root of 10 over 5. Yeah. Multiplying it and showing the 25 is me just showing it. If you know that it's going to be 5. Did you ask a question? Aaliyah, did you ask another question? Yeah. Like, I'm okay with you just doing the top part and going straight to the square root of 10 over 5. Is that what you're asking me? Yeah, I'm okay with that. All right, now, number 5, we can actually do 2 different ways. I'm going to show you both. Okay, again, we have the square root of 5 over the square root of 18. I want to, by a show of hands, raise your hands. How many of you multiplied by the square root of 18? Okay, so I'm going to do that way first, and then I'm going to show you a different way. So at the top, 5 times 18 is going to be 90, right? And 18 times 18 is, thank you. And we know that the square root of 324 is going to just be 18 because that's what I just multiplied by itself. Here's the question. Is 90 a perfect square? No. But does it have a perfect square that divides into it? Yes, we can start here and we can work our way back and we find that which one goes into it? 9. So I'm going to split that up into the square root of 9 times the square root of 10. And then I'm going to simplify. What is the square root of 9? 3. The 10 stays under the square root. And then what else can I do? Simplify which part? The 3 and the 18. I'm dividing them both by 3, so that's going to turn to a 1. That's going to turn to a 6. So then I get the square root of 10 over 6. Okay. Now, let me show you another way, because I did see a couple people do it this way as well. So if we split it up and we do the square root of 5 over the square root of 18. Yeah, tell me what you did on that one first. Yep. I thought it was something. Oh, never mind. Oh. Yeah. So some people recognize that 18 has a perfect square in it. And we can simplify first, which kind of, AJ, it was you that I saw, I think, right? Okay. That allows you to just deal with some smaller numbers. So what I can do first is I can split this into the square root of 9 times the square root of 2. Okay, which is going to give me 3 square roots of 2. That makes sense? Then what's the radical that I have to get rid of now? It's a much smaller number. 2. So all I have to do is multiply the top and the bottom by the square root of 2. Right? Which gives me then the square root of 10. And this is going to be 3 times what? 2, which gives me 6. So either way is fine. If you don't recognize that 18 has a perfect square in it, it works by multiplying it by 18. You just have to be able to deal with larger numbers. That's the only difference. Is everybody okay with that? Okay. Go ahead and write down number 6. What's different about 6? It's a cube root instead of a square root, right? So these are going to be a little bit trickier sometimes. So we're going to do the same thing we always do. We're going to split it up, and we're going to take the cube root of the numerator, and we're going to take the cube root of the denominator. But look closely at your denominator. Is 27 already on my list? It is, right? So 27 is a perfect cube. So I don't have to do anything other than simplify that. This 5 at the top is not a perfect cube, and it doesn't have a perfect cube in it. And what is the cube root of 27? 3. Okay, that got rid of my radical without having to do too much. Cube roots are a little bit different and a little bit more difficult when your denominator is not already a perfect cube, okay? So guess we're going to take a look at those. Is everybody good with 6? Okay. So take a minute and write down 7, and we're going to talk about this first. It is the cube root of the fraction 3 over 4. So again, I'm going to split it up, and I'm going to take the cube root of the numerator and the cube root of the denominator. Don't write this next part down. We're used to dealing with square roots, and so we're used to dealing with just multiplying the denominator by itself, correct? So if I do that, if I multiply by the cube root of 4, that's going to give me the cube root of 12 over the cube root of 16. Is 16 a perfect cube? It's not. So multiplying it by itself with cubes is not going to work most of the time. On a rare occasion it will, but most of the time it will not. So when you get to your cube roots in your fractions, this is how you want to think about it. Let's look at our denominator. Okay, cube root of 3 over the cube root of 4. What I need is I need that 4 to be able to turn into a perfect cube. So I'm going to go look at my cube list, and I'm going to start with the first perfect cube, not 1, because we don't want to go smaller, okay? We've got to go bigger. And I'm going to ask myself, can I turn 4 into 8 by multiplying? I can. What would I multiply by? 2. So guess what I'm going to multiply the top and the bottom by? Not just 2, but the cube root of 2. Okay. Why? Because multiplying 4 by 2 gives me 8, which is a perfect cube, which will allow me to simplify my denominator. Okay, so at the top, can I multiply the cube root of 3 times the cube root of 2? Yes, and that gives me the cube root of 6. At the bottom, the cube root of 2 times the cube root of 4 is going to give me the cube root of 8. And what does the cube root of 8 simplify to be? 2. And then at the top, does 6 have a perfect cube in it? No. And so that is what my answer would look like. So anytime you have a cube root in a fraction, what you want to do is look at the denominator. Start with 8. Can I multiply that number by anything to turn it to 8? If not, then we go to 27. If not, then we go to 24, and we keep 64, and we keep going until we find one that we can turn that denominator into. So go ahead and try 8. Actually, I want you to, do I have to split anything up? No, I don't have a whole fraction under a radical, right? My radical is just in the denominator. So I just need to focus on that. Is 9 on my perfect cube list? No. So I need to start with I can't start with 8 because that's smaller than 9. So we're going to start with the next one. Can I multiply 9 by anything to turn it to 27? Yes. What do I multiply it by? 3. So we're going to multiply the top and the bottom by the cube root of 3. Now at the top, do I actually multiply the 5 times the 3? No, it stays outside. Yes, ma'am. Because I need to turn 9 into a perfect cube. I can't turn it to 8 because that's smaller than 9, so I'll go to the next one. To turn 9 into 27, I multiply by 3. Okay. At the bottom, the cube root of 9 times the cube root of 3 is going to be the cube root of 27. And what is the cube root of 27? 3. Can anything else simplify there? No. Are we kind of okay there? All right, now with number 9, let's split it up first because I have an entire fraction under it. That 6 is going to go at the top with the cube root of 1. Then I have the cube root of 3 at the bottom. Do you have a question? Okay. Is everybody okay with how I split it up? Okay, let's start at the bottom. Starting with my smallest perfect cube that is bigger than 3. Can I multiply 3 by anything to turn it to 8? No. Can I multiply 3 by anything to turn it to 27? What do I multiply it by? 9. So I am going to multiply the top and the bottom of this by the cube root of 9. So at the top, I get 6 times the cube root of 9. At the bottom, I get the cube root of how much? 27. 9 does not have a perfect cube in it, so I leave that alone. The cube root of 27 is, sorry, how much? Thank you. 3. And then can any of that simplify? Yes. 6 and 3 can both divide by 3, so that's going to give me a 2 and a 1, so it's just 2 cube roots of 9. Is everybody okay there? Okay. Let's talk about 10. Take a minute and write it down. There are a couple of different ways we can do this, and I'm going to show you the shorter way first, and then I'll show you the longer way, and you can decide which one you like. Do you notice how in number 10 we have two numbers that are not under the radical at the top and the bottom and 2 numbers that are? So what we can do, the shorter way, is if they are both either not under the radical or both under the radical, we can simplify them first to give us some smaller numbers to deal with. So let's start with the first 2. Do 5 and 2, the ones outside of the radical, do they have anything in common? All right, so I'm going to leave those alone. But let's look at the two that are under the radical. Do 24 and 6. Can they both divide by the same thing? What can they divide by? 6. So that is going to turn into the square root of 4, right? And then the bottom is going to turn to the square root of 1. Well, not only did that give me some smaller numbers, what do we know about 4 and 1? They're both what? Perfect squares. So we can continue to simplify. 5 times what is the square root of 4? 2. Over 2 times what's the square root of 1? 1. Which is going to give me 10 over 2, which reduces to be 5. I could also, if that confuses me, do it exactly the way that we've been doing it. If I were going to do it the way I've been doing it, what would I multiply the top and the bottom by? The square root of 6. Okay. The only difference is I'm going to have some bigger numbers that I have to deal with. Is 144 a perfect square? What's the square root of it? 12. Okay. Is 36 a perfect square? What square root of it is? 6. 5 times 12 gives me 60. 6 times 2 gives me 12, sorry. And then 60 divided by 12 is 5. So either way, you can get to the same answer. It just depends on if you want to go smaller numbers or larger numbers. That are not under the radical, 6 and 5, do they have anything in common? No. And 32 and 4 can both divide by 4, so that's going to give me the square root of 8 over the square root of 1, right? Half people aren't looking at me. All right, so is 8 a perfect square? No, but does it have a perfect square that divides into it? Yes, so we are going to have to take that 8 and we're going to split it into the square root of 4 times the square root of 2. At the bottom, what is the square root of 1? Okay. So then we have 6 times the square root of 4, which is 2, times the square root of 2 over 5, and that's going to give me 12 squares of 2 over 5. That one can actually be done a few different ways, because what do you notice about that denominator, the radical of the denominator in the beginning? What is that square root of what? Whoops. Oh gosh, if I would write the correct numbers, it would help. This is the square root of 4. Isn't that already a perfect square? So you could also do it this way, by simplifying that in the beginning. However, we would then have to figure out how to simplify 32. Again, we're going to go to the closest one to 32 without going over. 25 does not go in, but 16 does. So I would split that up like that. Square root of 16 is 4. That gives me 24 square roots of 2 over 10, and 24 and 10 can both divide by 2 to give me 12 square roots of 2 over 5. And then you could also do it by just multiplying top and bottom by the square root of 4. There's a bunch of different ways you can approach some of these. You just have to think about it. All right, we need to hurry because we got a couple left. I'm going to talk to you about 12. When I have variables, yes, if it is a square root, you can always multiply it by itself. Sometimes that's a little too much, though, and I'll tell you what I'm talking about here in just a second. First thing I want you to do is split that up into the square root of 5 over the square root of x. Now, if I have x to the first in the denominator of my fraction and I want to turn it to a perfect square, what should I multiply the top and the bottom by? The square root of x, yes. So again, the first thing I would do is split it up. by taking the square root of 5 over the square root of x. And then you told me to multiply that by the square root of x, which would give me what at the top? The square root of 5x over the square root of x squared. 5 nor x is a perfect square, but at the bottom, what is the square root of x squared? X. Could I simplify those x's? No. Okay. But I want to show you one where we need to think just a little bit, okay? Is everybody good with 12? Right. Take a minute and write down 13. I want to talk to you about this. You can do this exactly like we did the last one, but it's going to require a little bit more simplifying. So what I want you to do is anytime you're dealing with fractions and you have radicals that have variables in the denominator, I want you to think about it like this. And I'll show you both ways that this works. If I have x to the third, and I need that to be a perfect square, think about this. The exponent on perfect squares is always what kind of number? Even. So if I have 3 x's, how many more do I need to make it even? Just 1. So really, in this case, all I have to do is multiply it by the square root of x. Okay, and let's look at that. At the top, the 2 and the square root of x stay the same. At the bottom, the square root of x to the third times the square root of x is going to give me the square root of x to the fourth. And what is the square root of x to the fourth? X squared. Okay, that's your short way. However, if you didn't think about it like that and you did exactly what we've been doing, and we multiplied it by x to the third, or the square root of x to the third. First of all, at the top, looking at your radical, doesn't the square root of x to the third simplify a little bit? How many times does 2 fit into 3? 1, with how many leftovers? And then at the bottom, 2 fits into 6 how many times? 3. And do you see anything that can still simplify? This x out front can cancel one of those at the bottom. So we would still end up with the same answer. It's just you have to simplify a little bit further.